Welcome to Beyonder Podcast. I'm your host Arnav and we have Saksham behind the camera. Today we have the privilege of sitting down with an industry luminary who has dedicated his life towards artificial intelligence and natural language processing. Our guest today is none other than Professor Monojit Choudhury, who is a renowned researcher and currently a professor at Mohammed bin Zayed University of Artificial Intelligence. In this episode of Tech, we'll look into Professor's journey into the tech space and what his views are on the current state of artificial intelligence and what the future of this technology is. So without any further ado, let's begin our today's episode. Welcome to the show, sir.
Thank you.
So you completed your education back in 2007 and ever since that you have been working in this artificial intelligence sector, and even before people knew what artificial intelligence was. So how did you make this decision? What made you choose that I'll choose this as my career?
I would say that was a very serendipitous thing. I was interested in research always, but I was more interested in theoretical computer science, and in those days, computational biology was hot. So I'm talking of 2002 when I was in my final year. And then in my final year, I was working on a small project which everybody had to do as a part of the curriculum, different projects for different people. And I was working on how to make machines speak Hindi. So you type in text-to-speech system, as we call them. You type it in Devanagari characters and give it to the model, and the model should be speaking it out. And it was not able to pronounce Hindi words properly because in Hindi, certain us are not pronounced and certain us are pronounced. So that was the problem. It's technically called schwa deletion. And I really loved working on that problem. So those were the days before deep learning and also before the big boom of machine learning. So machine learning in NLP was just coming in, right? It was there. So the work that I did was an algorithm which was trying to understand how the language exactly worked and trying to give a solution, which was very accurate solution. And that gave me a lot of confidence that, I can invent, algorithms that work. And also it was very useful because it solved a problem which the lab, my professor working on that time, Professor Anupam Basu, so his lab was struggling with, and it solved the problem. So I was also very happy. So it started from there, and then I thought, this area and languages are pretty fascinating. We never look at languages like that. They have structure, they evolve over time, they change over time, and there is a rule or law behind all of this. And people have studied, linguists have studied for a very long time. And that's how I got interested in language. And since my background was in computer science, I started seeing how language can be studied computationally. And of course, natural language processing was already a field. It's one of the earliest fields in artificial intelligence. Like ever since AI started in 1950s, NLP or natural language processing was also part of it. So I just got into it and there was no looking back after that.
We'll come to the languages part back, but for our audience who might not know what these terms are, can you give a brief description of what language models are and what NLP is?
Sure. So NLP or natural language processing is a set of tools or techniques to use language in automated systems. So example could be, can you order a phone to set an alarm for you just by giving a voice command instead of pressing buttons or writing a command, or querying about let's say some information by just typing, which we all do in search engines. So search engines are also sort of tools which process language at some level. So anything that tries to process human language is under the purview of broadly NLP. Now, it looks very easy because to humans it comes very naturally. Human babies learn language without any supervision from the age of 2.5, and by 5-6 years, they are perfect speakers of the languages they are exposed to. But when we start processing it through computers, it becomes very, very hard. It becomes very hard because languages have a lot of ambiguity. Even a simple sentence like, I saw a monkey with a banana. People might just think there is one meaning, but there are at least 12, 13 meanings of this sentence. You are cutting down a monkey, sawing down a monkey with a banana. You are watching a monkey with a banana. There are all these possibilities. And to kind of narrow down the interpretation to one possibility requires a lot more information than just the knowledge of the grammar or the words. You need to know word knowledge. So, for instance, banana is not an instrument for seeing. Common sense reasoning. So it's more likely for a monkey to hold a banana than I holding a banana and watching a monkey. So all these things become very important. So that's why it's a very hard problem. Now, what language models are, in very simple terms, given a prefix of a language, text, or even speech. So by prefix, I mean, let's say I give you 10 words of a sentence. Can you complete this sentence? What words are more likely to come after that? So this is the fundamental, function that a language model kind of serves. It just can generate language given what it has already seen. But in today's world, like in last maybe 5 years or 7 years, we have come up with these technologies called large language models, which essentially does the same thing, but so efficiently that now you have models like ChatGPT, where you can ask any questions and it seemingly answers. You ask it a puzzle, it tries to answer. You ask it to write an essay or a poem or anything with following certain constraints, like write a poem with 14 lines, with alternate lines rhyming, it will write for you. So it seems like it's able to reason, it's able to do a lot of things. But actually, what it knows, the only thing it can do is how to complete sentences. So essentially, your instruction is given, your whatever query question, and it's just trying to complete it. So that's in short what a language model is. And these large language models are essentially super capable versions of language models which can complete things very, very efficiently as if they are following instructions.
So what I understand is it's just pattern recognition. It's understanding the pattern. This word mostly comes after this word, so it might be right. So is this what it is doing?
Yeah,
Pattern.
It's exactly like that. So if I say it's raining today, so I went out of the house with my, most likely it will be umbrella or raincoat, right? And not, let's say, sunscreen. So that's what a language model can do. But you see, to do this, automatically it means you have some knowledge of the world, right? It seems like.
Yeah.
But actually, it's just learning those word probabilities from large amount of what we call corpus, text that you can scrape from the internet, from the books, from blogs, etc.
So the same thing happens with images today nowadays. So for example, Photoshop's generative fill, what it does is it sees an image and it tries to fill in the empty parts. So how different is that? How are those algorithms different from these algorithms? The base fundamental thinking, is it the same or are these things different?
At one level, these things are quite different, and I will try to explain you why. So, image is what we call a continuous system, whereas language is a discrete system.
Okay.
By discrete system, what I mean is if you take a word like cat and change one letter C by B, another letter, you have made a very minimal change, but the meaning has totally changed, right? Back. So it's not a continuous system. You cannot slowly morph, the letters and get slightly different meanings.
Right.
But in image, you can change a pixel and it will probably not even make an effect. You can't recognize. You change a few pixels, the image will be only slightly different. You can slowly move the camera angle little by little, the face will shift, tilts, and it's a continuous system. Things are moving very slowly, continuously in space. So when you are dealing with continuous systems, things like deep learning or many other mathematical or computational techniques are very capable of handling the data. Whereas when you deal with discrete systems, those techniques don't work because simply things are not differentiable. It can't be modeled as a mathematical function. So, so therefore, um, deep learning took a long time to make an impact on NLP. Actually, if you see, deep learning's initial impact was on computer vision, like image recognition and all this, and that's where big, breakthroughs happened. Around 2010, it started. It's only after 5 to 7 years that things got moving in computer in NLP, and that was with this idea called embeddings. So we do in embeddings is try to map words to vectors. Once you map them to vectors, they are like numbers, and you can slowly change them. A vector can slowly change in space. And the idea was that two words which are similar in meaning should be very close to each other, so that you slightly change. And so that's not the property of cat and bat. But if I have a vector for cat, it might be very close to a vector for, let's say, dog, because they have some similar properties. So that's the notion of embedding. And large language models are nothing but a way to train very good word embedding models. Essentially, they have very good representation of the meanings of the words in context. This is done through the process of trying to predict the next word.
Also, we are hearing about these terms in the last 1 or 2 years. It was not there before that. It was there for developers and all. For general people, general populace, they had no idea.
Right.
So why now? Why in 2023, or why now? Why not 5 years ago, or why not 10 years ago? What happened right now that was missing back in the days? What was the pivotal moment that skyrocketed the growth of these apps? Because now today we have chat GPTs for everything, from reading a PDF to generating images. We have AI for every single thing. It has become a buzzword for everyone. So why now?
Yeah. So partly, I think that question presumes a lot of things, which is because probably people are not aware of the history that
Right.
much. So, as I said, NLP, or language understanding, was one of the first problems in AI, which Alan Turing, father of AI, he himself propounded this notion of Turing test, which is essentially a chatbot at how, can a human judge distinguish between a chatbot and a human? And if not, then that particular chatbot is so good that it can fool a human judge to believe that it is a human, and therefore it is intelligent. So that's Turing test. Now it's quite natural then this whole definition itself includes language understanding. You can build a very good chatbot if it can understand language. So therefore, if you can solve NLP, so that way NLP is very old. And if you look at the history of AI, there has been what we call AI winters and AI springs, and AI winters and AI springs, right? And there has been many a times when people thought NLP was solved. So one example is there was a chatbot called Eliza, which made similar noise like like ChatGPT made today, but maybe not at that same scale because social media was not there, and also for many other differences. However, it did make a lot of buzz, right, in those days. But it was a very, very simple chatbot. It was a rule-based chatbot. Of course, soon people realized that it is not so useful, and it really, this really doesn't push the boundary of NLP. And things kept moving. So the progress that you see from outside, and it just looks like it has happened overnight, there's a long history to it. People have done a lot of work over time, built data sets, built techniques and everything to come to this level and built ideas. Now, from a popular point of view, right, a layman point of view, what was the turning point was, I think, ChatGPT. When ChatGPT came out, somehow everybody talked about it,
Yeah.
right? Before that, also we had BERT. So for me, the biggest wow was not ChatGPT or GPT-3. In my personal, opinion, for me, the biggest wow was multilingual BERT, which many people don't know. Like if you ask people, lay people around, everybody will have heard about ChatGPT. And multilingual BERT came in 2018, 2019, around that time, just a couple of years before GPT-3. And it had the capability that you train a model for only English and it starts working for hundreds of other languages, of course, to various capacities. And this was like really a wow for me because I have been working in this space for a very long time. And multilingual NLP, especially for Indian languages, where there's less data, it's very hard to make
Right.
good models. And this was like, oh, wow, you don't even need data, you just need data for English and it starts working in all these languages. So, but people don't know. Now, why ChatGPT made a lot of news? I think one was the interface. It was a very usable interface, and people could immediately see that it could do. I mean, it could write poems on random topics,
Yeah.
right? So that made a big impact. But to also put things in perspective, why now? So I think the biggest thing that has happened. So as I said, innovations have been happening all through. So the concept of embedding existed since 1950s with Wittgenstein, and even in 1990s, people like Sudo May had predicted that Word2Vec will come one day, right? And they speculated ideas like this, and they had their own version of embedding, which is called latent semantic analysis. So the ideas are were all there, but the large scale engineering and the GPUs and then making them to work at that scale and scraping data at World Wide Web scale and training the system. That engineering was one of the primary things which also changed the things, I would say. It's not the technical ideas because they have been around. Even RLHF, which is claimed to be the core of ChatGPT and what is like GPT-4, had been there for quite some time.
So, say if after 50 years, when we look back at this, because today we are living in the beginning of this AI revolution. So, after 50 years, if we look back, and if there is a page in Wikipedia about history of artificial intelligence, what would people put there? Which model would you say that this was the model that revolutionized or made a huge change?
So I think in terms of which model, of course, many of these models will come there. ChatGPT will certainly come there. Like I'm talking of Eliza today.
Yeah.
So people will talk of ChatGPT. But 50 years later, people might say, oh, there was a lot of noise about this model called ChatGPT. People thought AGI is here. Next came GPT-4, and there were claims that there is sparks of AGI. But soon people realized that, it doesn't solve the AGI problem. And there were a lot more work that needed to be done to integrate multiple modalities, integrate symbolic logic, symbolic reasoning, integrate logical understanding, etc., etc. Eventually, which led to where we are today. Of course, I don't want to speculate where we will be in 50 years. Like in 2018, experts were asked to say when certain NLP problems will be solved, and they predicted 2050, and then in 2 years, all those problems were solved. So experts are also as bad in predicting, the future as anybody else.
What are the problems that are restricting the boom of AGI? Why do we not have AGI yet? And what are the problems that we are facing?
Hmm. This is a very good question. I think the first problem is definition of AGI itself.
Okay.
So people really don't agree on what is AGI, right? What should a system do to be called that it is AGI? And there is no such definition. Even if you try to come up with a definition, there will be other experts who will disagree with the definition and will give their own definition. So recently there has been a lot of debate on this topic. So Sebastian Bubeck wrote this paper where he tried, from Microsoft, where they talked about sparks of AGI and gave a lot of great examples of why it does seem like the model has capabilities beyond, just statistical processing of language. However, there were lots of papers after this which criticized this and said why it was wrong, that was wrong, and so on and so forth. So overall, I think the biggest problem of answering that question is because we don't have a definition of AGI. If there was a very concrete definition, it would have been much easier to answer it this way or that way, right? But if I were to still answer why, what's the biggest hurdle in AGI, I would say it's what we call language grounding. So, language is used always in a context. It makes meanings are always, not only in the context of a sentence, but the context of the conversation, the context of like which room we are sitting. If I say, I can't see your face because of the poster, you will immediately realize that this is this poster I'm talking about. Now, unless that grounding is there, this doesn't make any sense, right? Unless this view of the room is there. So essentially, language doesn't operate in isolation. It operates in the context of the physical environment we are in, the mental models of we have of each other, which we build over time of a long time of interaction, the personalities of the people, and lot of other things. And I think this, just by training models on text, we can never get to there. So, what is the answer? Is it multimodal? I think multimodal takes it one step further, but still is not the answer, because you are. How do we train multimodal? So here is an image, here is a caption. So you understand the image, you understand the language, but language being used in this, real world and with all its complexities, and if you want to model to that level, all the input modalities that you need to get and all the data, I don't think we have the ability to capture that data in a practical way, at least today. I see more interesting promises that can be offered probably by a metaverse, where people live and interact, and and then the data generated from there could be used to train more,
Interesting.
AGI kind of models.
We have been talking about languages, and you have been talking about languages since a long time. You have researched about them. So, I'm from Maharashtra. I speak Marathi and I speak English. But my Marathi is much worse than my father's. My father's Marathi is worse than his dad. And the kids that I'm seeing today, their Marathi is even worse than what I know. I think language is dying off. This is happening with other languages also. So, how do we save this? Because everything, the technology that we are using, it's all English. But we are a multilingual society. We don't just speak one language, we have multiple languages. So, we need to have these technologies on all of the languages. But the problem that we have is we don't have data. So, how do we solve this problem?
Yeah. No, that's a question very close to my heart, and I would answer that. But before that, I want to point out that your Marathi is, I don't think, not necessarily worse than your father's or your father's from his father's. I think language always evolves, right? Any language evolves,
Right.
and that's how it evolves, right? So if you take English from 16th century and English from 17th century, or Marathi from 16th century, Marathi from 17th century, and you look at the older literature and everything, it will be a very different language. You can't even recognize it, right? So any language that changes is usually considered healthy. A living language always changes. The moment you language stops changing, it's inevitable. Its death is inevitable, because the world is changing, right? And the language has to describe the world. So the language has to take concepts from the world. So your language has to. So there was no LLM before, let's say, 2020. So now LLMs are there. So languages must have a word for it. So languages have to evolve. So, and because of society, how it evolves, the culture evolves, so the languages are evolving. So that's what you are seeing. So it's different. Your grandfather's language is different from your father's, which is different from yours, which is different from kids. Typically, in 5 years, language changes.
Right.
I mean, you can recognize, but you can clearly see the generation gap in language, and that's the reason. However, you have definitely a very valid point, which is there are around 6,000 languages in the world, and only 3,000 of them were ever written. And even those which were written, most of them were written in a script which is not part of the community. It's a script of the colonizers. So naturally, there is very written text. So if you go beyond the 100, 200 languages in terms of the available material on the digital material, or even otherwise, right, printed material, after that, you will find hardly any text data. for rest of the languages. So we are talking of 6,000 languages and maybe 500. So rest, right? 5,500 languages have very minimal or to zero text data. Now, all the technologies that are based on text, like all the chat GPT, GPT-4, by design are not including those languages, are not thinking about those languages, right? So those languages can get no help from these models. We need to have other kinds of LLMs which directly work with speech. So that's one. Now, even the languages which are supported, let's say 500 to 1,000, which has some text that you can find, um, the problem is, so the problem is at multiple levels actually. So one level of the problem is there's a huge skew in the amount of text that's available, let's say in English versus in Hindi versus in Kannada versus in Santali. So English probably has 100 to 100, not even 100, maybe 3 orders of magnitude, 1,000 times more text than Hindi. And similarly, Hindi has probably an order of magnitude more text than Kannada. Kannada has probably a couple of orders of magnitude more than Santali. So when you train a model with all these texts, clearly the accuracy or the performance you get for English and that for Hindi will have a gap, and same for Santali. More importantly, if you train a single model, it has a benefit, like I said, you train the data with, train a task for a language, it starts working on another language. So that's a good part. But the bad part is for a language like Santali, if you try to do this, the accuracy will be much lower than for, let's say, if you go from English to Hindi, because Hindi to start with had more data. So that's one problem. And we had this work where we studied the languages of the world, and it seemed like, more than 88% of the world's languages spoken by 1.2 billion speakers, none of these technologies make any sense. I mean, they cannot bring any direct benefit, deep learning technology. So this is one concern. The other concern you already mentioned is, so languages represent not only words and meanings, but also a worldview. I was talking about it when I was talking about it operates in a context. So since a language operates, like if you talk of languages of the Andaman Islands, so there is a context there, there's an environment, there are volcanoes, there is an ocean, there are certain biodiversity, wildlife. And the language is used to describe those, describe their mythology, describe their daily life, and so on. Now, all these details are lost when that language is lost. And we are losing one language every 2 weeks. Oh. That's the rate, alarming rate at which we are losing language. In fact, UNESCO initially declared 2019 as the year of endangered languages, or year of indigenous languages, to increase awareness about building technology. I mean, building technology is one strong aspect of that program in indigenous languages. But then they then they thought 1 year is not enough. So they described the whole decade, 2019 to 2029, as the decade of indigenous languages. So if you are talking of how technology can help Andamanese languages or how technology can help Santali, so really a lot of work is needed, and it's a long way. And in my personal experience, since I have worked with languages like Gondi, Mundari, which are actually spoken by millions of speakers. Gondi is spoken by more people than, let's say, I think, Polish. But even then, it's a hard work. And unless the community comes forward and tries to, make sure that they want to work on their language and build technology that they need, it's very hard. It's very hard to scale. You can do one language, right? I can pick one language as a researcher. I can do a work. I will work for 10 years, build a lot of things. And it's not about building, right? After building, it has to be used. It has to be sustained. So either there should be a commercial thing. So if there is a commercial thing, then Microsoft, interest, then Microsoft will do it. Google will do it. But if there is no commercial interest, which is the case for most of these languages, then only the community can come forward and try to build. And people can help, like researchers can help, big companies can help, NGOs can help. But the urge has to come from the people themselves.
The communities has to grow socially and economically.
Yes, but also they have to have that. See, language is very strongly tied to identity. Like you said, I'm a Marathi. right? You are a Marathi speaker. That's a very strong part of your identity. I am a Bengali speaker. So Bangla is a very strong part of my identity. So if you think of your language as a part of your identity, then you will learn it, then you will try to preserve it, pass it on to the next generation. If you don't think of it as a part of your identity, you want to come out of it. And that's how languages die. It doesn't die because all the people in that community were dead. They have moved to another language, right? And why? Because they have not considered that language to be their identity because of socioeconomic reason. If I learn another language, I will be able to do it better. I will be able to. So all these factors are there. So it's a very complex socioeconomic problem, not only a technical problem. And I think individual communities have to come forward. Only then those languages, we can do more.
Right. Uh, Also, in one of your research paper, you talk about 6 different types of languages. Can you explain that in a bit?
So this was very related to what I was just talking about right now. We looked at the uh, languages that people have worked on, and the amount of data that exists on the web, because most of the LLMs are built on the data straight from the web, and the amount of data that exists in language resource repositories, which are more, how what we call label data, which is more hand curated and can be used to test how good the models are on different things, or even fine tune or train a little bit. So when we look at these different kinds of data availability across the world's languages, it so turns out that there are some languages which have a huge amount of data of both kinds, and you can do a lot of things for them. And there are only 7 languages in that set, and this formed, I think, class 5. And examples are English, Chinese, and so on. Only 7 languages. Then there was this other category of languages which we call class 4, which has reasonable amount of data in both or in both the web and also these curated language resources, and therefore they will quickly get to that point.
Okay.
And Hindi is there. Hindi is the only Indian language, I think, which was there. And then you have category 3, where a lot of effort is needed to push them there. Category 2, which seems unless the communities come in, nothing can be done. And categories 1 and 0, which probably nothing can be done because they were never written. So there is absolutely no data. So unless we move to a very different paradigm of modeling, we can't do anything.
Because they were not written, they are just spoken languages. So is there some technology that, like we train written data, can we train audio data? And so is there something work going on this?
Yeah, so there is a lot of work going on the speech side of things. How can you use audio data to train models? But these models are mostly like, when you have both. So there are 2 kinds of models. How can you generate speech, or how can you transcribe speech? So you give speech as input and you get transcription as output. Now, what we are talking about is we give only speech as output, and it learns a model to recreate speech from speech to speech, right? There is no text in between. And can it work for languages with very little speech data? I'm not a speech researcher, so I don't know the latest work, but probably even a year ago, I don't think there was much. I mean, before the generative AI era, there had been work where people tried to do this kind of things, and in smaller pockets, still a lot of interesting research is happening. But with the generative AI, like building these large scale models with only speech data from maybe 3,000 languages, is anything happening? I don't think so. I would have known if it was happening. The biggest efforts are around 1,000 language or 1,500 language models from Google and Meta, which they are talking about. But in both cases, they are talking about text.
Also, Nvidia's stock has skyrocketed because GPUs are in a lot demand right now. So, question is, why is GPUs used in this AI sector, and why not CPUs? What's the difference?
So the deep learning, algorithms both the training algorithm and the inferencing algorithm involves a lot of matrix multiplications. Matrix multiplications and tensor multiplications, right? And these matrices or tensors are huge, right? Their dimensions could be, in tens of thousands. So such big matrices, when you are multiplying on a CPU, so matrix multiplication is an n square operation, and n is very large. So it takes a lot of time. But GPUs are designed in such a way that matrix multiplications can be parallelized.
Parallel process.
Yeah, it can be parallelized very fast. And therefore, you can do matrix. They are, you can think of these as, while GPUs were not built specifically for deep learning, but GPUs turned out to be, the kind of hardware which are very specifically targeted at doing matrix multiplication kind of things. So therefore, they could be repurposed for deep learning very well. And you can therefore, that made, building chat GPT like system or even GPT-3 like systems possible. You could train at large scale.
Okay, coming to an end, we have a lot of students who are interested in this topic. So for students who want to pursue a career in AI, how should they start? What topic should they learn who are in first year, second year? How should they start their journey into this sector?
So one thing, which is worrisome is, because of all this hype, because everybody knows LLM. So I was visiting my school. So I grew up in Northeast in Agartala, and I visited my school a few days after the release of ChatGPT, probably a week after the release of ChatGPT. And I asked in class 9, 10 students were there, how many of them had heard about ChatGPT? Everyone. It's a great sign. I was very happy that, Agartala, which was a very remote place when I was growing up. A movie would come after 1 year. People have heard about ChatGPT just in 3-4 days. But the worrisome part of this is things are progressing so fast that if you try to follow the space, you will get mad very quickly. It's like every day something is happening as if like the world is breaking. But most of these things, if you look back, after 10 years, probably meant nothing. Like the small thing.
Right.
But you don't know today which ones are important and which ones are not. So even for researchers, it's very difficult, and for students, it's definitely going to be very, very confusing. So what I would suggest is, it's a good idea to follow certain, one good thing is a lot of people on social media have tried to maintain channels where they put curated content like YouTube videos and all that thing. So if you manage to follow some of them, at least you will keep getting the curated content and you don't have to look at everything, and only the diluted version. If you are interested, you can go and read the paper. At the same time, you should do 1 or 2 projects. I think the best way to learn these things is through hands-on, exercises. And these days, it's very easy to do it. Like I teach a course at Lakshya University, and there, earlier when we used to do the projects, even in 2021, 2022, people would come up with a prototype in it's a 6 weeks course, so people would come up with a prototype. Some parts of it will be working, some parts of it will be not even working, and so on. In 2023, everybody came up with as if like it were finished products. Why? Because technology has progressed so much that now building all these, great looking, applications is just a matter of API call and a prompt.
Right.
People could do it, and then you put a fancy GUI around it, and it looks like a finished product. And I was telling them, oh, in 6 weeks you have, just go and sell it as build a startup and sell this thing. So I think it's very easy to play with these tools and these things, and people can do some meaningful projects, try to build things, and this will be very good way of learning.
Can you tell some of the projects that students can try? Some basic ones.
There are many, right? One simple thing could be, if you don't speak English, suppose you speak any Indian language, just go and evaluate how good ChatGPT or GPT-4 or Llama or any model is in your language, where it fails, what it can do, what it can't do. And from there, try to get an idea of, why things doesn't work and what will be useful if Llama could do that in your language, for instance.
Okay, let's conclude our today's episode. Thank you, sir. It has been a wonderful opportunity to talk to you, and I'm sure we can talk about all of these things again sometime. Thank you for coming.
Thank you for
Wonderful
having me
talk.
here. It was a pleasure talking to you.